Welcome to section 7.3, Law of Cosines. In this section, we have one objective: solve problems involving triangles using the law of cosines. So far, we've used the law of sines to solve many triangles. However, the law of sines doesn't always apply, particularly when we are given two sides and the included angle, so SAS case or side angle side case, or when we know all three sides, side, side, side case. In these situations, we need a relationship called the law of cosines. This formula allows us to find missing sides or angles when the law of sines is not enough. The law of cosines is a generalization of the Pythagorean theorem that applies to any triangle, not just right triangles. It relates the lengths of the sides of a triangle to the cosine of one of its angles. The standard forms of the law of cosine is c squared equals a squared plus b squared minus 2ab times cosine c. Similarly, by rotating the roles of the sides and angles, you have the following two formulas. So a squared equals b squared plus c squared minus 2bc times cosine a, b squared minus a squared plus c squared minus 2ac times cosine b. Please note that the capital letters are the angles and the lowercase letters are the sides. So when we know all three sides and want to find an angle, it's helpful to isolate the cosine first by rearranging the law of cosines. So we'll rearrange the law of cosine or its equivalents in order to solve for the missing angle. Since the capital letters are the angles, we would want the trig function and the angle on the left-hand side and all other terms on the right-hand side. So rearranging, we get cosine C equals a squared plus b squared minus c squared divided by 2ab. And then similarly, we get the following two formulas for cosine A and cosine B. Okay? So this version is especially useful for solving triangles in the side, side, side case, meaning you're only given the lengths of the triangle. So here are some steps to help us in solving triangles using the law of cosines. So solving for missing sides and angles using the law of cosines. So if given SAS, which is two sides and the included angle, so an angle between those two sides, we are going to use the law of cosines to find the missing third side. Then we'll use the law of sines or law of cosines again, if we prefer, to find the missing angles. If given SSS or side, 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 meaning we know all three sides of our triangle, we'll use the law of cosines, more specifically the rearranged form of the law of cosines, to find one angle. Then we'll use the law of sines or the law of cosines again to find the remaining angles. All right, so let's do some examples together. So in this example, we're asked to find the missing parts of triangle ABC if A is 48 degrees, so that's angle A, side B is 15 inches, and side C is 25 inches. So let's draw a triangle to help us. All right, so I'm going to label this A, B, C. Those are my angles. I know angle A is 48 degrees. I know side B is 15 inches. And I know side C is 25 inches. Okay. So we need to find all of the missing parts. So that would be angle B, angle C, and side A. Okay. Note that what's given here is a side angle side triangle. So we have a side, which is 15 inches. We have an angle, which is 48 degrees, and another side, 25 inches. So let's first find side A. Okay, let's find side A. So to find side A, we are going to use the law of cosines. So that's A squared equals B squared minus C squared minus 2BC times the cosine of angle A. That would be 15 squared minus 25 squared minus 2 times 15 times 25 times the cosine of 48. Simplifying the terms, we get 225 plus 625 minus 750 times cosine 48 degrees. We can enter this whole expression in our calculator and we'll get a squared equals 348.152. So we'll take the square root of both sides, and A approximately equals 19 inches. Okay? So now we know the length of side A. Okay? So next, let's find an angle, one of the two missing angles. So we have angle A and we have angle A, but we need to find angle C and angle B. So now which one would we choose first? Would it be B or would it be C? Well, we know that side A is 19 inches. So that would mean B would be the smallest angle. Angle B would be the smallest angle, and angle C would be the largest angle. So we're actually going to find angle B first because it's the smaller angle. How do I know B is the smaller angle? Well, since the side length B is smaller than the side length C, the angle B will be smaller than the angle C. So let's find angle B. All right. And we can use the law of cosines or the law of sines to help us. Let's use the law of sines just to review a little bit of what we've previously learned. So I'm trying to find angle B. So I am going to have to use the ratio for A to help me because I don't have a complete ratio for C. So I'm going to utilize A over sine A equals B over sine B. Okay? And this will get me 19 over the sine of 48 equals 15 over the sine of B. All right. So let's cross multiply. So I'll have the sine times, 19 times the sine B equals 15 times the sine 48. Then I will divide both sides by 19. So that will eliminate the 19 on the left-hand side. I'm going to enter in 15 sine 48 divided by 19 in my calculator, and I will roughly get 0.5867. This value is between -1 and 1. Therefore, it can be a value of the sine of an angle. Since this value is positive, I want to locate the quadrants that have a positive value for sine, and that would be quadrant 1 and quadrant 2. Okay, so I'm going to need to find two different angles, one in quadrant 1 and quadrant 2. That'll give me a positive 0.5867. So we'll take the inverse sine of 15 sine 48 divided by 19. I want that whole value. I don't want a rounded value so that I can get as accurate as possible. And when I enter this in my calculator, rounded to the nearest degree, I will get 36 degrees. Now 36 degrees is in quadrant 1, so that will be my reference angle. So to find the other angle in quadrant 2, I will have to subtract 36 degrees from 180 degrees, which will get me 144 degrees. Okay. Now you might stop and say, oh, I have two solutions for angle B. But since we have quite a bit of information already provided for us in our triangle, we can utilize that to help us determine whether both of these angles or only one of these angles works for our specific triangle. So 36 is less than 48 degrees, which makes sense because side B is the shortest side, which means angle B should be the smallest angle. Okay, so that works. Now 144. If B is 144, that would mean that B would have to be greater than angle A, and angle C, which also means that the side length B would have to be greater than the side length A and the side length C, which is not the case. Okay, so 144 degrees can't be a solution for B because angle B is an acute angle since it is smaller than angle A and angle C. So the solution for angle B will be 36 degrees. Okay. Now that we know B is 36 degrees, we can label it in our triangle here. All right. And so now we need to find our last missing piece, which is angle C. And to find angle C, we now need to utilize the triangle sum theorem that says all of the angles within a triangle sum to 180 degrees to find our missing angle. So let's do that. So for 3, we're going to find angle C. So C will equal 180 degrees minus A plus B. So 180 minus 48 plus 36. And this will sum to 96 degrees. Okay. And so we found our last missing piece, which is 96 degrees. So we have all of the missing sides and angles for our triangle. All right, our second problem here says that the diagonals of a parallelogram are 28.2 centimeters and 36.4 centimeters and intersect at an angle of 60.4 degrees, find the length of the shorter side of the parallelogram. So let's first draw our parallelogram here. All right, and we'll draw our diagonals. Okay. All right. Diagonals of 1 is 28.2, and the other one is 36.4. Since they bisect each other, we can divide them both by 2 to find what half of each diagonal is. This one would be 14.1, and this one would be 18.2. So we will have 18.2 over here and 14.1 over here. Now the angle that's formed is 60.4 degrees. This would be 18.2 centimeters, and over here would be 14.1 centimeters. Okay? All right. Now we want to find the length of the shorter side of the parallelogram. Okay? So this would be the shorter side. Oh, I put my angle. Let's move our angle. That's more of an obtuse angle. We want it to be in the acute side, 60.4 centimeters. Nope, degrees. Okay, there we go. Okay, so 60.4 is less than 90, so it's an acute angle, so our side will need to be shorter. As you can visually see here in my image, although not drawn exactly to scale, where I originally had the angle is more so an obtuse angle, which would represent the longer side, and we want the shorter side. So to draw it accurately, I would need to give the acute angle the 60.4 degrees. And then that would give me an angle or a triangle that has an SAS or side angle side, which will allow me to utilize the law of cosines to solve for my missing side. So we'll give that side C, and we know C squared is A squared plus B squared minus 2AB times the cosine of angle C. So we'll substitute in our values. So that's 14.1 squared plus 18.2 squared minus 2 times 14.1 times 18.2 cosine of 60.4 degrees. So C squared here, which is x squared, that's the missing side that we're trying to find, is approximately 276.5393. When we take the square root of both sides, we'll get 16.6 centimeters. So the shortest side of this parallelogram is roughly 16.6 centimeters. All right, for triangle ABC, we need to solve the missing pieces if length A is 26 kilometers, length B is 19 kilometers, and length C is 15 kilometers. So let's first draw our triangle. Okay, so we have angle A, angle B, angle C. Side A is 26. Side B is 19. And side C is 15. Okay, so we're trying to find all of the missing angles. which means we have all three sides. So since we have all three sides, we can use the arranged form of the law of cosines to help us find one of the missing angles. Now, which angle are we going to do first? Well, when you are given all three sides, my recommendation is for you to find the largest angle. Now, the largest angle is going to be associated with the longest side. Since the longest side is side A, that means my largest angle is going to be angle A. So let's first find angle A. So using the rearranged form of the law of cosines, we'll get cosine A equals B squared plus C squared minus A squared divided by 2BC. We can then substitute in our given values for A, B, and C. When we have that in, we are going to enter that value into our calculator, and we will get negative 0.1579. This value is between negative 1 and 1, so we can then take the inverse cosine of this value, and we'll get A approximately equaling 99.1 degrees. So now we know A is 99.1 degrees. All right. So next, for step 2, we are going to find our next angle. Since we know the largest, let's find the smallest. And so that would be angle C, because length C is the smallest length. All right. So we know the ratio, a complete ratio for side A and angle A. So we can use the law of sines to help us find angle C. So our ratio for A is 26 over the sine of 99.1. And then for C, we know the side, but we need to find the angle. So we can cross multiply. Remember, the goal is to get C by itself. And then divide both sides by 26. And then we will take the inverse sign to get us the value of C, which is approximately 34.7 degrees. Okay, so C is 34.7 degrees. All right, now that we know two angles, we just need our third angle, which is angle B. Okay, so we can now take the two angles and enter it into our triangle sum formula. So I'm going to find angle B. So B equals 180 minus A plus C. 180 minus 99.1 plus 34.7. So B approximately equals 46.2 degrees. Okay. And so that was our missing piece. All right. And so we have all of our missing angles. Awesome. Let's do one more. All right, problem number 4. A plane is flying with an airspeed of 205 miles per hour with a heading of 105 degrees. The wind currents are running at a constant 35 miles per hour at 155 degrees clockwise from due north. Find the true course and the ground speed of the plane. All right. Well, to help us out visually with this problem, let's draw an image. All right. So a plane is flying with an airspeed of 205 miles per hour with a heading of 105 degrees. Okay, so let's say this is north, all right, and a plane's path, this is the plane, it has a heading of 105 degrees, and its airspeed is 205 miles per hour. So we'll give that B. So the speed, airspeed, and direction of the plane will be V. All right, and we know V is 205. Okay. Now the wind currents are running at a constant 35 miles per hour at 155 degrees clockwise from due north. So the wind affects the speed of the plane, okay? And it is moving at a constant 35 miles per hour at 155 degrees clockwise. So this would be 155 degrees. And this speed would be, let's give it W. The W would be the speed and direction of the wind. And this equals 35 degrees. Okay? Now we want to find the true course and the ground speed. So let's connect this. So there's vertex, vertex, vertex. We connect this, we form a triangle. So we want to find the magnitude of V plus W, or in other words, the speed of the plane with respect to the ground. Okay. All right. So this is the information that is directly given to us from the problem. Okay. Now, what other information here could we utilize to help us? Well, we have some unknowns. Okay. So this angle here, we can give a symbol. So let's give that theta. This angle here, we can give beta. And this angle here, to complete a circle, we can give alpha. So we know 155 alpha and theta altogether equal 180 degrees. Okay. So in doing so, we then know that since we have two parallel lines here, we know that corresponding angles are the same. So we can figure out what alpha equals. Well, alpha will be 180 minus 105, which equals 75 degrees. So we know now that alpha is 75, which means we can then find theta. So theta would be 360 minus 155 plus alpha, which we know is 75 degrees. So when we subtract that sum from 360 degrees, we'll get 130 degrees. So we know alpha is 75. We know theta is 130. Okay, so what do we then need to find? What are we looking for? So remember, we're trying to find the true course and the ground speed. So the true course is going to give us the direction, and that is going to be given to us by angle beta. Okay, that's going to be the true course. Now we need to find the ground speed, and that is going to be given to us by v plus w, or the speed of the plane with respect to the ground, because the speed of the plane is affected by the wind current. Okay, so we need to find angle beta, and we need to find the length v plus w. Okay, so we can utilize our law of cosine and law of sines to help us. Since we know side, side, angle, side, we can use that to help us find our missing angle and missing side, v plus w. But which one are we going to do first? The missing side. Side angle side allows us to use the law of cosines. When we have that side, we can then utilize the law of sines to help us find our missing angle. All right, so let's do that. So I'm just going to sketch our triangle here real quick. We drew, and so this was beta, and this was theta, and we know theta was 130 degrees. This was 205, and this was 35. And we're trying to find this length and beta. Okay, so let's find the magnitude of v plus w, in other words, x. So x squared will equal 205 degrees plus 35 degrees minus 2 times 205 times 35 times the cosine of 130 degrees. Okay. When we enter that into our calculator, we will roughly get 52,474.0022. When we take the square root of that value, x is approximately 229, and this would be miles per hour. Oops, didn't need an extra hump there. Okay. All right, so I used the law of cosines to help me find my missing length, x, or in other words, the speed of the plane with respect to the ground. Okay. So now we are going to find the direction. We're going to find beta. Okay, because that's going to help us identify the true course. All right, so let's find beta. So we will have 35 over the sine of beta equals 229 over the sine of 130 degrees. We can cross multiply. And I want sine beta by itself. So I'll divide both sides by 229. I'll then take the inverse sine of the right-hand side to find beta, which is approximately 6.7. But we're going to round that to the nearest degree, which is 7 degrees. All right. So remember that our plane was flying. All right, our plane was flying with an airspeed of 205 miles per hour. Okay. And it had a heading of 105 degrees. The wind was running at a constant 35 miles per hour. And that was going at 155 degrees clockwise from due north. We found that the speed of the plane with respect to the ground was 229 miles per hour. Okay. And we now need to find the true course from the plane. And we found this short angle here, which was beta, is 7 degrees. So the true course from the ground is going to be the total angle distance clockwise from where the plane originated from. So in other words, it's going to be 150 degrees, 105 degrees, plus 7 degrees, which is going to equal 112 degrees. So the true course of the plane is going to be 112 degrees. And we used beta to help us find that. Okay. All right. That concludes section 7.3.